Alright guys, so today we're going to be talking about the Baeyer-Villager oxidation reaction. And this is where we want to take our carbonyl, which in this example we have a ketone, and react it with meta-chloroperoxybenzoic acid in order to form another carbonyl molecule, which in this case will be an ester. So here's the mechanism as follows. So first we need to draw our carbonyl, which in this case, once again, is a ketone. And then let's draw out our reagent, which is mCPBA. So this is what our reagent looks like. We have a chlorine, which is attached to our benzene ring right here from the double bonds. And then we have this long chain of oxygens and carbons that looks a little like this. So now what's going to happen is that we have our two lone pairs right here, and it's going to grab the hydrogen at the end of this molecule right here, moving those electrons onto the oxygen. So now what we get is our carbon-oxygen double bond still intact, and then this oxygen here has a single bond to a hydrogen, meaning it has a positive charge. So then we can draw in our mCPBA reagent again, and just to abbreviate, we will draw this chlorine and this benzene part as an R to make our life a little bit easier, so we don't have to keep drawing it over and over again. So let's draw that out right here. And this negative charge is going to attack our carbonyl carbon right here, putting those electrons onto the oxygen. So now what we get is our oxygen and our hydrogen up here, our alkyl group down here, which is this part, and then we have our oxygen right here, and then the rest of our molecule. So now what's going to happen is we're going to have a 3 curved arrow step mechanism step here, because this is going to help us set up for our last step in the reaction. So what's going to happen is that this part that has 2 lone pairs is going to form a double bond right here with our carbon, and we are going to perform an alkyl shift in which this carbon-carbon bond here jumps onto the oxygen to form a carbon-oxygen bond, and this bond breaks right here. So now what we get is, I'll draw the molecule down here, is our carbon-oxygen double bond reformed. Our oxygen has a positive charge. And then we have our oxygen here with our alkyl group that we shifted from here at this point to there. So now what we can do is we can bring back our used up mCPBA, which looks like this. Negative charge here on the oxygen, and it'll grab the hydrogen right here and move those electrons onto the oxygen there. So then what we can get is our formed ester, and then we have a byproduct which looks like this. And this is a carboxylic acid, which we can use in other reactions. So now, what we started off with one carbonyl right here, which once again can be a ketone or an aldehyde, we've done a reaction and we've formed an ester and then a form of a carboxylic acid. Because remember, our R would just be our chlorine in our benzene ring that was derived from our mCPBA. So this is the complete reaction and mechanism for the Baeyer-Villager oxidation. Have fun with it. I hope this helps, and I'll see you guys in the next video.